let's continue. Right, can we continue now? Let's have a look. Let me just have a quick check. Oh, where's my attendance sheet gone? I'm missing Ray, I know, and Dasha as well. Who else am I missing? Just those two? I'm missing no one else? Feels like I'm missing someone else. Oh, I just can't see everyone. Okay. Right. Trig equations. Okay. So, with the help of your calculator, here's a simple equation. Sine theta minus a half equals 0. What's theta? So see if you can give me the theta here just to get started. What's the theta? 30. It's 30, yeah. Because sine 30 degrees minus a half equals 0. However, if you use your calculator and type in sine 150 minus a half, you'll also get 0. So a little bit like this problem, x squared equals 9. What does x equal? Plus or minus 3. However, what answer does the calculator give you? It just gives you the 3, doesn't it? So something similar is happening here. The answers occur in pairs. The calculator only gives you half of that. So the question now is, how can I get the other half? So just to be clear what happened here, you said sine theta equals a half. Theta equals sine inverse a half. Calculator said theta equals 30, but there's a second answer of theta equals 150. How can we get that? Let's have a look. 180 minus the 30 is how I got it, yeah. There's a couple of ways to think about this, but one easy way to think about it is with this circle. And then you draw two lines through it like this. So, the way this circle works is, if you have, usually your calculator is giving you the acute angle. For example, here it gave me 30 degrees. Usually so. If you have the angle here, and you want the second angle, then if it's a sine equation, you get the second angle by looking here. If it's a tan equation, it's here. Now if it's a cos equation, it's here. Now how does this work? So we got the first angle is 30. So this distance here, how big is that? It's also 30 because it's a mirror. But we don't want this angle. Where do we measure angles from? We measure angles from this line. So if I start here and go all the way around to this angle, what do I get? 150 if this here is 30. Now let me give you another example with tan. Okay, so let's have a look. Let's say we have this equation. Oh jeez, which one? Let's say I have tan 30, tan theta equals root 3. So what does theta equal? So what's theta? Tan inverse root 3. What do we get? 60. So what we're saying is that this angle here is 60. The second angle we get is all the way over here. It's a complete extra 180 degrees over the other side. So if this angle here is 60 and this angle here is 180, then what is the total from this line all the way around to here? Yeah, 60 plus 180, which is 240. Now, to confirm your answer, simply type in tan 240 and make sure you get root 3. Yeah? Now, if you do not like this circle, no problem. I can give you this in a 3-sentence form. So, if you have a sine equation, then the way you get the second answer is equal to 180 minus the first answer. If you have a cosine equation, the way you get the second answer is by doing 360 degrees minus the first answer. And the last one is the one we just did. If you have a tan equation, the way you get the second answer is by doing 180 plus the first answer. So if you do not like your ASTC circle, you can simply remember these 3 facts for giving you the second answer. Is this enough? Yep.
There's also quadrilateral angles, so are they
Which angles?
like 390?
Ah, yeah, I didn't actually say this. You're right. I have it in my question, but I didn't write it down. I was only looking at between 0 and 360. So I should have said at the start here, theta is between 0 and 360. Yeah. Okay. Can I scroll down? Yeah? Right? Yeah. So let's have a look at a harder example now. 2 sine squared x minus 3 sine x plus 1 equals 0. And I'll tell you that x must be between 0 and 360 degrees. Okay. So it looks like a complicated equation with sine x, but when you look closely, what type of equation is it? Quadratic. Let's factorize. Well, it has to be a 2 sine x, doesn't it? And a sine x. Oh, and the 1 means it has to be a 1 and a 1 here. The question is, what's the signs? It has to be a minus and a minus. So it has to be this, doesn't it? Yeah, this is it factorized. Okay. So, 2 sine x minus 1 equals 0, or sine x minus 1 equals 0. That means sine x equals 1 over 2, or sine x equals 1. Now let's get the first answer on the calculator. So the first answer is sine inverse a half, and that's 30. Or, well actually, while we're here, we might as well get the second answer. So how do I get the second answer? 180 minus 30, so that's 150. Now, here, the first answer is sine inverse 1, 90. And the second answer is 180 minus 90, which is 90. So actually there's only really one answer on the right. So we finish by saying x equals 30, 90, or 150. Okay, can I scroll down? Yeah. Okay, next type of problem, something like this one. Once again, let's confine x to be between 0 and 360. And let's say we have the equation sine 3x equals, let's say just 1 over root 2, for example. Now this problem is a little bit different now because we have a sine 3x, whereas previously we just had sine x. So we get 3x equals sine inverse 1 over root 2. So we have 3x equals 45 degrees. And the second answer is, what is it? 135. But what's different about this one is there's more than 2 answers. I wonder, in fact, if anyone knows how many answers this one should have now. In total, it should have... Nope. Are we just going to start counting up? No. 2? No, I just said it has more than 2. So we know it's not 2. 6. As 6 answers. Okay? Because what happens is the effect of having the tree triples the number of answers you have. So normally you should have 2, but if you triple that, now we have 6. And if this is 4x, we'll have 8 and so on. Although now there's a problem. We know how to get the first answer. How do we get the first answer? By using the calculator. We know how to get the second answer. It was 180 minus the first answer. But now the real question now is, how do I make those other 2 answers? Other 4 answers. So does anybody know how you get the next 4 answers?
That's 360.
What do you do?
Plus 2 plus 360.
That's it.
But the range is
I,
limiting.
no, you can't both give me the answer and then doubt your answer. So which is it? Are you going to give me the answer or not?
Yeah. Plus 360.
Okay, good. And then stop there.
Yeah.
Okay. So the way you make the extra answers, if it's sine, cos, or tan, is by adding 360 to the first 2 answers. So with the help of the calculator, if I add 360 to this one, what do I get? 405. And then what do I get next?
495.
495, isn't it?
Yeah.
And if I add 360 again,
765.
765, and then 360 to this, 795? No, what is it? 855. But those angles are for 3x, and we would like to solve for x. So divide by 3 now. So 45 divided by 3 is 15. And then 135 divided by 3? What is it? 135 divided by 3 is definitely not 9. 45, thank you. 405 divided by 3 is, what's that? What is it? 135. Okay. And this one is
6.5.
6.5. Okay.
2.5.
And then 2.85.
Okay. Got it.
Now, let's check that this works. Let's pick a random example. Let's say this one here, 255. If it's a solution, then sine of 3 times 255, what should that equal? Should equal 1 over root 2. Well, why don't you type it in? Now, your calculator will probably give you the answer as root 2 over 2, which is the same thing.
Oh.
Yeah. Is that what you got? Minus? That's sad. Is it coming out with minus on everyone's? Oh, I think you mistyped something then. You got positives? Yeah? Karul? Positive? Yeah? Okay. Right. I have 2 more examples to do. Can I scroll down? Yeah? Okay. Two sine squared 2x plus 3 cos 2x minus 3 equals 0. And again, we'll keep x being between 0 and 360. Before we do this one, there's a rule I should give you. Maybe some of you know it, but it's useful for these problems. There's a rule that says sine squared x plus cos squared x always equals 1. Now this, believe it or not, is a version of Pythagoras. It's the version of Pythagoras in sine and cosines. You can see how it looks like Pythagoras. So this is actually just Pythagoras, just with sine and cos. This rule is something we'll need for this problem. What do I need to do? Well, if I use this rule, I can say that sine squared, what will that equal? 1 minus cos squared. Now that's useful, because what can I do here? I can change this into 1 minus 2x plus 3 cos 2x minus 3 equals 0. So that's 2 minus 2 cos squared 2x plus 3 cos 2x minus 3 equals 0. Let's take everything to the right. 2 cos squared 2x minus 3 cos 2x plus 1 equals 0. This has factors, doesn't it? 2 cos 2x minus 1 and cos 2x minus 1 equals 0. So I get cos 2x equals a half, or cos 2x equals 1. How many answers in total will I have from the first one? Maximum number of answers? 4. And here? 4. So 2x equals cos inverse a half. What's that, 60? And the second answer? No, you did it for sine. For cos, it's 360 minus the first answer. 300. Third answer? Third answer is 420. And fourth answer is 660. Isn't it? 360 and a 360 here. Yeah? Or, what's the first answer? Cos inverse 1 is 0, isn't it? Second answer? 360. Third answer? 360. Fourth answer? 720. Okay, what's to finish? Divide by 2. So you get x equals 30, 150, 210, 330, 0, 180, 180, 360. But 360 we reject because I didn't want 360 included. So we end up now with x equals 0. Let's do it in order. 30, 150, 180, 210, or 330. 1, 2, 3, 4, 5, 6 answers for this one. Okay, write that down, please. Yeah.
How can the quadratic equation get 6 answers?
It's a quadratic of a trigonometry. So it's not quite quadratic in x. It's quadratic in sine x. Okay, you got that? Yeah? Yeah. One more example I want to do. Okay. Can I scroll down? Yes, Matala? No, what's taking so long? Okay. YouTube, yeah. Like and comment later. Okay. Let's say I have something like 2 sine 3x. No, that's too big. 3 sine 2x plus 30 degrees minus 4 equals 0. And again, let's keep x between 0 and 360. Now, you have to be really careful with this one. Although it looks simple, the order is so important here. And I'll explain what I mean as I go through it. So the first thing we do is we just change this in this 3 sine 2x plus 30 equals 4. And sine 2x plus 30. Oh, Stephen, you blasted fool. I have my 3 and 4 mixed up. I'll have to change. 2, fine. 2. Okay. Right. So sine 2x plus 30 equals 2 over 3. What was the problem if I kept it as 4? Yeah, exactly. Yeah, we tried to avoid those. Okay, so 2 over 3. I think of these problems in 4 steps. So what I'm doing here is what I call step I, the inverse step. This is where you try to get it into a sine inverse problem. So here we can now say 2x plus 30 is equal to sine inverse 2 over 3. So actually, let me just put brackets or something. So for me, all of this is what I call the inverse step, getting to this stage. Right, what is sine inverse 2 over 3? Okay, so we have 2x plus 3 plus 30 equals, what did you say? Okay, so 41.81 degrees. Now this is critical. You must find the extra answers next. You can't take the 30 over and divide by 2. So this next step is getting the extra answers. Now we know how to get the next one for sine. It's 180 minus the first one. So what do we get here? 138.19. And we know how to get the next two answers by adding 360. So that will be 401.81. And then what's the last one there?
Should we add 50?
I just said, what did I just say? Is absolutely critical you find the extra answers first before you do any manipulation here. Didn't I just say that? I did just say that, didn't I? Right, so what's the fourth answer here? 498.19. Okay. Now, Carol, the next step is the simplifying step, where you deal with the 2 and the 30 to simplify it to x. Okay, so just to make it clear, if you had 2x plus 30 equal to an angle, and we have 1, 2, 3, 4 angles here, then what would you simplify x to? It would be the angle minus 30 over 2. This is the simplifying step. Let's simplify the 4 angles now. So, x equals, what's the first one? 5.9? 91, okay. Okay. 185.91. 234.1. Now, the last step is what I call the fixing step. This is where we have to fix any answers that fall outside the range. You see, you might be tempted to think, if you got to this step, let's imagine you got an answer of 400 degrees at this step. You might be tempted to think, oh, well, I reject this answer. But no, it's possible to fix any answers that fall outside the range. At the final step, you're allowed to add or subtract 360 to any angles to try to bring them back inside the range. Now, is that necessary here? No, because each angle falls inside the range. But if one of the angles fell outside the range, I could attempt to bring it back in by adding or subtracting 360. But it's not necessary here. So I have my 4 answers. So the order is I, E, S, F. You get the inverse, you get the extra answers, you simplify to x, and you fix any angles outside the range. So inverse, extra, simplify to x, and then fix any answers outside. Okay? Right, let me give you your questions. You can start now. All of question 1, because they're quite short, plus 2... FGH. Okay, you can get a start on that now. So, yeah, for 10 minutes only.